Hey everyone, recently I made a video about my new timer callback system. The goal was to find a timer callback system that makes the syntax of adding callbacks to your program a little bit more straightforward, while at the same time giving me easy access to different kinds of features like trying different FPS really quickly, or giving a callback a name, or not having to inherit from timer callback, or making a difference between animations that run endlessly and ones that just being triggered on certain actions. And also I wanted to have a timer callback that just runs on one single place, instead of having a million timer callbacks. But at the same time I wanted the code that is actually being used to use the new system to be as reduced as possible so that it doesn't get in the way. And I think I failed at that in my last video, and on top of that the structure that I presented was a little bit buggy. So I decided to make a follow-up video where I show you the actual solution. So here is the current plugin template. As you can see, I have already added my default parameter design with a knob, also with a modulation dial where you can change the bias value. Now I will show you how the animation is implemented. You can just perceive the fact that this knob updates its parameter value visually as an animation, because what's going on in the background is that my custom parameter attachment is constantly asking if the value has changed, and if yes, then it repaints the knob with the new values. The way I'm writing my custom parameter attachments is definitely a topic in itself, and I'm probably going to make a video about it because I have put a lot of thought into it already, but maybe I will work out a little bit more of the details before I do that. And for now I will just look at the syntax of the callback that I decided for. So as you can see, it's pretty straightforward. In the middle of your component you can just say add, and this automatically means that you want to add a callback because there is no other method that's just called add, and also because you are giving it a callback as an argument. And the callback itself has multiple input arguments. First one is a lambda that just describes the callback, and the second one is a name for the callback in the form of an enum, so it's actually a number. Update parameter cb, so this is the callback of updating parameter values. Then there is the FPS value, and there is the fact whether or not this should run all of the time or just be triggered on certain actions. So this is set to true because parameter values just have to be updated from the start forever. Now let's look at the actual callback itself. We try to find out if we shall repaint the component, and if yes, then we do that. And it basically depends on the parameter values being changed. So there is the main value, there is the modulation depth, and if macro is not 100%, then there is also val mod, which describes where the parameter value actually is. Then there is the modulation bias, which describes like the remapping of this modulation. And if any of that kind of stuff changed, then we update the values in some vector that is on this class, and then we say, yeah, we do have to repaint this component and do that. I also want to give you a little example of an animation that is not running endlessly because it looks a little bit different. For example, here we have a button, and when you're hovering it, then as you can see, it blinks up a little bit. So here in the constructor of the button class we have two different callbacks, kHover animation callback and kClick animation callback. So there's also an animation for clicks, but we are looking at the one for hovering. The other one looks pretty much the same though. So first of all, it's easy to just keep track of what's what and what the things are doing. Also note that I don't have to describe like how it should do things on different FPS. Like if I wanted to, I could just go ahead and change the FPS on the second one. It would automatically do its thing without me having to actively add any math or values or anything. With a timer callback class of juice, this would have been a little bit more complicated because once you have inherited a component from it, you can just let the timer callback run on one specific FPS. With the system, you are a little bit more free. Do whatever you want without really thinking about it too much. And this callback describes what the animation is like. There is a value called hover anyface in this class. It's always assumed to start at the number 1, and then it decreases to 0. And once it has reached 0, then the callback is turned off. So in repaint, the value hover any face is being used to draw the animation. So this was all nice and readable, but you want to know where the animation is being turned on. So you go into the mouse exit method where you can see kHover animation callback is being activated to true. Now this system didn't work in my last video. It was a little bit buggy. There was a bit of a problem, and I want to quickly show you how I solved this. If you are interested in my system and want to write something similar. So here is my component base class, and it has a reference to the Utils class, and the Utils class only exists once in the whole project, and it holds the place where all of the callbacks are being processed. So naturally it made sense to me that my component class has some methods for callbacks. And the most important one is the add function, which you have already seen in action. And under the hood, it does a little bit more than just adding the callback to the vector of callbacks of this component. It actually deregisters all callbacks and registers all callbacks. You know, every time before you are doing it, you are telling the thing that has all of the pointers to the different callbacks that it should remove all of these pointers. And after you have added the callback, I tell the thing that it should add the pointers again. This might look a little bit wasteful or stupid or something, but it's just foolproof, and I just wanted it to be as solid as possible, because what I had before was kind of hard to wrap your head around, and this just works. You don't have to be too pedantic about something that is mainly added in constructors anyway. The big problem was that sometimes when you are resizing vectors, for example by pushing back callbacks, the vector under the hood just puts the stuff somewhere else, and then if you have somewhere else a pointer to the same objects, then obviously that can't work. I should have known that. That's like basic C++ knowledge, but this just shows that you can always forget about these kind of things in some moments where you are not the brightest light on the table, or whatever that wordplay was. So let's just quickly look into the Utils class, which has add and remove, which are both very simple. Timer callbacks class, as you can see here, the object, it exists once per instance of the plugin, just like everything else in my Utils class. I can only recommend everyone to have a Utils class in their plugin editors, because that's a great way to make a distinction between the kind of editor state that should be, let's say, global for this instance, and the kind of state that is global for all instances together, which would be more of a static kind of thing, just in order to get these not too mixed up. Actually, I would like to know how other people like to call these kinds of classes. I just decided that it's Utils, but it could be anything. How do you call these kind of things? You already saw my timer callbacks class in my other video, in the actual timer callback. I didn't really explain it very well in my other video what this thing actually does, so I decided that I wanted to give this a little bit of a try, even though I'm not very good at explaining math. So as you can see, here is an index, and it gets incremented once per timer callback, and the timer callback runs on 60 FPS. So every 16 timer callbacks it wraps back to 0. So here we get the FPS, and then we do this thing on it, and this means, just as GitHub Copilot already suggested, a value 1, 2, 4, 8, 16. The reason for that is because 2 to the power of 1 is 2, and so on and so on. GitHub Copilot knew what I wanted to say again. Yeah, we have these values 2, 4, 8, 16. Actually, this should start with like that. Okay. 1, 2, 4, 8, 16. And as you can see now, if you do modulo with it, then that makes a lot of sense. For example, you are in the second state, 1. Which FPS is represented by the number 1? It is 30 FPS. So that would mean every other index value, so 0, 2, 4, 8 and so on, will trigger this to be true. So in other words, every other timer callback is triggering 30 FPS. And you know, it goes on and on like that. For example, here with the number 4, it will take 4 timer callbacks to trigger the next FPS, and that's why it is K15. So that's the way I made sure that my pretty complicated looking two-dimensional array of callback pointers processes callbacks on different FPS without actually having to, you know, do any fancy calculations in this timer callback. I will definitely keep my other video online, even though it had a little bit of a buggy implementation in the final presentation, because it also had some of my historical moments when trying to update my timer workflows. For example, here I just showed how in an earlier version of my timer callbacks I had this moment where I implemented it in a way where you have to manually call update timer on each component that you have, which just looked really ugly, and it was error prone because sometimes I just forgot to do that, and then I was wondering why it didn't work. So that last video, even though it wasn't very representable for my work, definitely shows like all of the different considerations that went into the final solution that I presented now, and that's why I think it's actually quite valuable. I would still like you all to give me your opinion. Like, are timer callbacks a thing, a problem for you? Do you ever feel like held back from your workflow because the timer callbacks are just not very flexible? Which other features could you imagine a timer callback class or structure or code style could add in the future? I don't know. What else comes to your mind and stuff?